This video presentation is brought to you by the Pro Mathematics Academy. Welcome back to another video presentation brought to you by the Pro Mathematics Academy. In this video, we'll be looking at functions and how we can specify what the domain of certain functions can be. Okay, so we'll jump right into our tutorial exercise set. And here we're looking at question number 1, which asks us to find the domain of the following functions, right? And the first thing we want to note for question number 1, we're given f of x equals 7x plus 22, right? So here we want to note that f of x is a linear function, okay? Right? And what is a linear function? A linear function is a function of the form f of x equals mx plus c, okay? So here we want to make a special note that linear functions are defined for all real numbers. Okay, so here we have no restrictions on our domain. Therefore, if f of x equals 7x plus 22, then the domain of f is equal to the set of x in real numbers, right? Without any restrictions. Another way we could write this in interval notation is that we define x over all real numbers in between negative infinity and positive infinity, not inclusive. Next, we move on to question number 1, part B, right? And here we have the function f of x equals x squared plus 4, right? And here we will also make a note. This time, we want to note that f of x is a quadratic function, right? And what is a quadratic function? A quadratic function is any function of the form f of x equals ax squared plus bx plus c, okay? So here we see that we have a quadratic function, and our final note, right, is that all quadratic functions are defined for all real numbers. Okay, so with that said, we can say that if f of x is equal to x squared plus 4, then we can say that the domain of our function is equal to x in the set of real numbers. And as previously defined, we can also write it in interval notation, just like that. Moving right along, we now move on to part C of question number 1. This time we have a function that is very similar to what we had before, okay? And because I'm so predictable, of course, we're going to start by noting the type of function that f of x is. So here, we say that f of x is a cubic function, right? And what is a cubic function? Of course, a cubic function is any function of the form ax cubed plus bx squared plus cx plus d equals to f of x. Okay, let's keep the standard consistent. Okay, and likewise, we'll say that all cubic functions are defined for all real numbers. Okay? All cubic functions are defined for all real numbers. So now we can say that if f of x is equal to some cubic function x cubed minus x plus 1, right? Then we can say that the domain of this function f is equal to the set of all real numbers without any restrictions. Okay? Now moving on to part D. If we notice for part D, we have a different type of function, right? And let's note the type of function here. So note f of x here is a rational function. Okay, and what is a rational function? That's what everyone is wondering. So we group all functions that are of the following form to be rational. So f of x equals g of x over h of x, right, is rational if g of x is a polynomial and h of x is a polynomial. Okay, so what are polynomials? Polynomials are the set of functions including linear, quadratic, cubic, quartic, quintic, and all higher power functions. Okay, so I know that's a lot to note, but that describes the set of all polynomials, right? And here we want to recognize that if we have a rational function, so we say if f of x is equal to some g of x over h of x, then f of x is defined where g of x is defined and h of x is not equal to 0, but defined. So this implies that we must solve x squared minus x minus 12 not equal to 0 here because that is our denominator. So whatever this denominator function is, h of x, we must make sure that that h of x is not equal to 0. Okay? So if we're solving this, this means that we end up with x minus 3 times x minus 4, okay, not equal to 0. And I know somebody's thinking right now that something is off. So here, that's a positive 3, which implies that x is not equal to negative 3, nor x is equal to, so I guess let's change that. X is not equal to negative 3, and x is not equal to positive 4. Okay? So therefore, our domain in this question is equal to the set of real numbers, right? Where x is not equal to -3 and x is not equal to 4. There we have our answer. Okay, so the important thing to note here is that once we have a rational function, right, we must always make sure our denominator is not equal to 0 and we are defined everywhere else. Okay, moving right along to our next question. So for this example, we need to note that note here that f of x is a radical function, otherwise called an irrational function. Okay, so what is a radical function or irrational function? The word radical means square root or third. So once we realize that our expression has in it a square root of a function, right, then that function is a radical function. Okay, so this is the general rule of thumb. If f of x is equal to the square root of some type of function g of x, then f of x exists everywhere g of x is greater than or equal to 0. So we need to solve the inequation g of x greater than or equal to 0 for x. Once we do that, then we'll be able to write down our domain. So now f of x is equal to the square root of x squared plus 3x minus 28. Right? So this implies that we need to solve x squared plus 3x minus 28 greater than or equal to 0. And if we're solving that, okay, it would mean that we need to first find our roots, right? And then we'll say that x is less than the smaller root or x is greater than the larger root. So this means that if I should factorize my expression, I'll end up with x minus 7 times x minus 4. And I know somebody's thinking that one of these signs is incorrect. Of course, the bigger sign, the bigger number gets the front sign. So of course, this is a positive 7. So now we see that x equals -7 or x equal positive 4 are the roots. So this means we have a -7 right there, and this means we have a positive 4 right here. And in order to solve the inequation, we need to say that x is less than -7, right? Because -7 is the smaller root. And we need to say that x is greater than 4 because x equal 4 is the larger root. So this is the larger root, and this is the smaller root. So we always need to say x is less than the smaller or x is greater than the larger whenever we're solving this type of inequation. Okay, what is this type of inequation? Here we're saying that the quadratic must be greater than 0. Okay, so once we're solving a quadratic greater than 0, we need to always end up with the answer in this form: x is less than or equal to, I'm missing my equal to here, right? X is less than or equal to the smaller root, or x is greater than or equal to the larger root. So let's write down our domain. So here our domain of f in this case turns out to be x in the set of real numbers where x is less than or equal to -7 or x is greater than or equal to 4, right? Is there another way we could have written this in interval notation? Of course. So here we have negative infinity, right, up to -7, inclusive of -7, union +4, inclusive of +4, all the way up to infinity, not inclusive. Okay, so this is just another notation, right, which is called our interval notation. Okay, and here we have our set builder notation, just in case you guys are wondering what is the name given to each of these notations. Okay, so next we move right along to solve part F. Okay, so let's clear this one out of the picture. Okay, so what type of function do we have here for part F? First, let's make a note. Note that this type of function is a radical function, right? Otherwise called irrational, and we talked about the properties that causes a function to be irrational before in the previous question, part E. So here, we need the square root of x plus 3 to not be equal to 0, and we need x plus 3 to be greater than or equal to 0. Okay? So we need to find a way to satisfy both of these conditions. Okay? So condition number 1, if the square root of x plus 3 is not equal to 0, this means that x plus 3 is not equal to 0. So we now get x is not equal to -3. And if I solve for x plus 3 greater than or equal to 0, I end up with x plus 3. Well, I guess I'm rewriting the same thing here. X is greater than or equal to -3. So if I combine these two conditions, right, I should end up with x is greater than -3. Because here I'm saying x is not equal to -3, and here I'm saying x is greater than or equal to -3. So if I combine these two conditions, right, it takes a while before it starts to make sense, but I'm sure after thinking about it, eventually we will get it, right? So therefore, if I solve this question now for the domain, right here, the domain of our function turns out to be x in the set of real numbers where x is greater than or equal to, no, x is greater than -3. Okay, and the interval notation for this one is -3 up to infinity. Okay, so now we look at part G, which says that, so let's add another page here. Okay, so for this type of question, we see that we have a radical in our numerator, and we have a difference of two squares in our denominator. So, note, what type of function is this? A radical function, otherwise called irrational, of course, because the radical is what makes it irrational. Okay? So what are the conditions that we need to satisfy here? One, we need the square root of x minus 4. Well, we need the function underneath the square root, which is the x minus 4, to be greater than or equal to 0. And we need our denominator x squared minus 25 to not be equal to 0. Okay? So these are the two conditions we need to satisfy. So now, x squared minus x minus 4 greater than 0 implies that x is greater than or equal to 4. So we finished with that part. And x squared minus 25 not equal to 0 implies that x minus 5 times x plus 5 is not equal to 0. So therefore, x is not equal to 5 and x is not equal to negative 5. Okay? So we have both of these conditions here. Condition number 1, which is given from our numerator. And now we have these two other conditions. Okay, so how do I combine both of these conditions? Right? So this part is a bit nasty, but after thinking about it for some time, we should get it. So we have x greater than or equal to 4 and x is not equal to 5 and x is not equal to negative 5. If these three conditions are to be satisfied, we end up with x is greater than or equal to 4 and x is not equal to 5. Okay? So therefore, our domain for this function is equal to x in the set of real numbers such that x is greater than or equal to 4 and x is not equal to 5. Okay, if you have any questions, feel free to comment down below. Okay, we move on to part F. We move on to part I. Okay. Oh, we move on to part H. Okay, so for part H, we know that we still have a radical function, of course, right? Nice. So now what are the conditions that we need to satisfy? First condition is that we need x plus 3 to be greater than or equal to 0. And part 2, we need x squared minus 16 to be greater than or equal to 0. But 3, we need the square root of x squared minus 16 to not be equal to 0. Okay, so once we find the set of x values that satisfy these three, then we can write down our domain. Okay, so if x plus 3 is greater than or equal to 0, this implies that x is greater than or equal to negative 3. Okay, that's 1. For part 2, if x squared minus 16 is greater than or equal to 0, this means that we have x minus 4 times x plus 4 is greater than or equal to 16, greater than or equal to 0, right? Which now means that x is less than negative 4 or x is greater than 4. Okay, and that's simply coming from our derivation from before. Once we have a quadratic expression greater than 0, then we will end up with x less than the smaller root or x is greater than the larger root. It's a principle that goes right across the board. Okay, so now we move on to condition number 3, which says that x, the square root of x squared minus 16 is not equal to 0. So this means that x squared minus 16 is not equal to 0, which means that what? X is not equal to negative or positive 4. Okay, so now we have all the conditions that we need to satisfy. So let's write them down. So we need x to be greater than or equal to -3, and we need x to be less than -4, and, well, or x is greater than 4. Keep writing greater than or equal to. Greater than 4, and x must not be equal to, I guess intuitively I was writing the correct thing. X must not be equal to -4 or +4. Okay, so let's see how we can combine all of these criterias. So if x is greater than -3, right, then it means that x cannot be less than -4. So let's write that one out. So if x is greater than -3 and we have x greater than or equal to 4, then we need to not have -4 and +4 in our solution. So therefore, we see that combining these three conditions together, we end up with x is greater than or equal to -3 and x is not equal to 4. Okay? So now, this means that the domain of f here is the set of x in real numbers where x is greater than or equal to -3, but x is not equal to +4. Okay? Nice. We then move on to apply what we've been doing so far to a different type of function, right? And these functions are logarithmic functions, right? So our first function here that we're going to be looking at is f of x equals to the log of x. So what type of function is this? This function is a log function. Okay? Right? And the typical log function, right? Log of x is only defined where x is greater than 0. So this means that our domain for f in this case is equal to the set of x in real numbers, of course, where x is greater than 0. Okay, it cannot be equal to 0, but it is greater than 0. Okay, and we can also write this in interval notation. Okay, so that is in interval notation. We have the set of x values in between 0 and infinity, not inclusive. Okay, so let's go. So here we can apply the same theorem to say that x plus 2 must be greater than 0. So this means x is greater than -2. So therefore the domain for this function is equal to the set of x in real numbers, of course, where x is greater than -2. Oops. Okay, moving right along, we now move on to part K, which says that here we need 3 minus 4x to be greater than 0. So this means that 3 is greater than 4x, which means that 3 over 4 is greater than x, which means that x is less than 3 over 4. So now we can go ahead and write down our domain for this function. And here we'll write x in the set of real numbers where x is less than 3 over 4. So whatever we solve our inequation for, that's the additional parameter that we add to our domain function. Okay, and I think this function here is our last function right? Before we jump right into question number 2. So here we need, this is also a log function. Okay, ln is another way of representing the log function, right? So we want to say that is log base e, okay, but it doesn't change what we're about to do. So we need x squared minus 4 because that's the parameter that's inside of the log function, okay? So whatever this function is that is inside of the function, we take that and we try to solve it for that greater than 0. So this means now that we have x plus 2 times x minus 2 greater than 0. So if we were all paying attention, this is in the said form that we were talking about before, right? Where we have a quadratic being greater than 0. So therefore, we need to find our two roots here. The roots are x equal 2 and x equal negative 2. So if I put this on my graph, I'll end up with negative 2 right here and positive 2, which means we must have x less than negative 2 and x is greater than 2, okay? So with that said, we can now write down the domain for our function here as x in the set of real numbers where x is less than negative 2 or x is greater than positive 2. Okay, and that's it for question number 1. That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.